In question 2, here we're being given 500 students this time and they're taking an algebra test. The scores were normally distributed with a mean of 75 and a standard deviation of 7. Label the mean and the 3 standard deviations from the mean, and then we're asked to work out the percentages. So again, we're just going to start by looking at the these kind of segments that we've broken it up into, or these intervals. So we know, remember, that the highest point on the graph is the mode because it comes from a histogram, and then we know, because it's normally distributed, the mode, median and mean are all the same. So this line here has to be the mean. Then what I can do is start filling in the standard deviations away. So every single segment here is broken up into a standard deviation, right? So we're a standard deviation away from the next line each time. So this here is going to be 82 and 89, and then we're going to have 96. And how did I get that? The mean is 75, so that's that piece of information. Standard deviation in the question is 7. So every single line there, that one, and that one, they're 7 away. Working backwards this way, we're going to have 68, 61, and then take away 7 from that again, and we get 54. So, looking at the questions then, we're being asked what percentage of scores lie between 61 and 82. So again, I'm going to identify those two pieces here and here. 61 to 82, sorry, that's the wrong interval. This one, 61 to 82. So this region here is 34%, this region here is 34%, and this region in here is 13.5%. How do we figure out then the probability or percentage or proportion of people that lie between those? Well, we just add them up. So if I add up 34, 34 and 13.5, we should get 81.5%. The next question then is going to be between 75 and 82. So I'm going to draw my line 75 to 82. Well, we know, we just actually used that. It's 34%. And where am I getting these numbers again? Back up, go back at the start of your worksheet, go back to the last video. We were looking at the empirical rule, where we know that if it's normally distributed, it's broken up into these segments by their standard deviations. And those segments have a particular percentage associated with them. So we've got 34% here. The next one is what percentage of scores between 61 and 89. So let me just draw those intervals again. So I'm going to go 61 to 89. Well, between those two, that is symmetric, and it's 2 standard deviations away. And if we're 2 standard deviations away either side, it's 95%. So we should know that from our empirical rule, nice and easy. The next one, what percentage of scores is less than 61? So I'm going to go to 61, and we're now looking for this segment down here. Well, if you remember from our empirical rule, this segment down here between the second and third standard deviation is 2.35%, and we learned also earlier that this little piece on its own is 0.15%. So if you add those two together to get the part that's below 61, we get 2.5% altogether in that yellow patch. Part E then. So part E, what percentage of scores is greater than 96? Well, here's 96 and we're looking for outside 96. So that patch in there, which we know is 0.15%. Okay, and if you're not sure about where I'm getting these, go back to the empirical rule again. The next one, part F, what percentage of scores is greater than 89? So we're now not looking at this part, we're looking for greater than 89. So I'm going to label or highlight the 89 patch for myself. And well, look at that segment. We've actually drawn something very similar to that before. Remember, we did 61 and below. Those are the same. So the answers should be the same between below 61 and greater than 89. It's the same answer. And again, why are we allowed to do that? Symmetry. It's symmetric. It's the same. So use that to your advantage. The next one, part G, approximately how many maths students scored between 61 and 89? Now, be careful again, the question has changed. We're no longer being asked for a percentage. It's how many students. So how many students lie between 61 and 89? Well, we've already calculated the percentage. Look, we worked that out. 61 to 89 is 95% of the population, or the students that we're talking about. And if we want to figure out then how many students that is, well, 500 took the test and 95% of them got between that. So if I multiply that, I'm going to get out 475 students. So 475 students got between 61 and 89. The next one, part H, approximately how many math students score between 61 and 75? Right, so we actually have to work out that percentage first. So 61 and 75. So let's take a look. 61 to 75. Nice and easy, not too bad. So we've got this segment down here, and it's going to be 34% inside those two intervals, and then 13.5% here. So I'm going to add those two together, and we get 47.5. Now that's 47.5% of 500 students, so we're going to multiply that by 500, and if I do that, I get 237.5. Approximately how many students scored between 89 and 96? So 89 to 96 is this region inside here. Again, first thing I'm going to do is work out the percentage. And we know that that segment in there is 2.35%. So I'm talking about 2.35% of 500. So to get that, I'm going to multiply it by 500, and I'm going to end up with 12.5. And a point to note actually about both of these last two questions, something I didn't catch on H, is that we can't have a half a student. So we're going to have to round it, okay? So you can't have a half a student. So we're not quite at the full student with this answer. So if I was to say how many students are between that, I would only take 237. Okay, because the half student isn't a full student. We wouldn't round up in that scenario. We haven't crossed over into 238. The same thing with this question here. I wouldn't round up to 13. I haven't quite reached 13 yet, so I would round it down actually to 12. So the rounding involves a little bit more thinking in these statistics questions. So just take your time with them and keep an eye out.